Hi, hello, and welcome to the second session of our day 3 polynomials. The fourth question is, what is the zero of the polynomial x square minus x minus 12? So what is zero of the polynomial? Before that, let me get down a little bit because this is second degree polynomial. It needs a little bit of more explanation, and to understand it, you need to understand a polynomial with lower degree. Let us take x minus 2. Let this be p of x. Now I ask you to find p of 2. Then what happens? Let us see. So in place of x, you will put 2. 2 minus 2 is 0. So you finally got a 0. So by putting 2 in place of x, you are getting 0. So what did you put in place of x to get 0? 2. So this value which you put in place of x or the variable to get 0 is called 0 of the polynomial. Is called 0 of the polynomial. For example, we have y plus 5. Now let this be p of y. Now I am asking you to find p of minus 5. So p of minus 5 is, in place of y you will put minus 5. So minus 5 plus 5, its value is 0. So by putting minus 5 in place of y, you got its value as 0. Therefore here the 0 of the polynomial is minus 5. So it is very easy here. But how to find a 0? Let us see. So we are finding out the 0 of a polynomial. For example, let us take x plus 5 as discussed just now. So what is the concept? Its value should become 0. So its value should become 0 by putting something here. So simple, you equate it to 0 and then find out the value of x. That becomes a 0. So for example, you keep this one here. So 5 comes here to become minus 5. So x is equal to minus 5. Therefore, this is the 0 of this polynomial. Does it really become so? Let us check. So in place of x, you will put minus 5. So plus 5 is equal to 0. Therefore, this is the 0 of the given polynomial. It's very simple. You equate that polynomial to 0, of which you have to find out the zeros. For example, you have to find out the 0 of 3p. What do? Simple, equate it to 0 and p will be here. So 0 by 3. Now its value will be equal to 0. Therefore, 0 of this polynomial 3p is 0. Right? We have understood how we can find the 0 of a first degree polynomial. Now let us take the second degree polynomial. This is also called quadratic polynomial. So the rule is the same. We simply equate it to 0. Equate it to 0. Then take away all constants and find out the value of x. Is it possible here? If you take away 12, here both of them remain and it becomes a little bit tough. So let us see how we can do it. We have a separate chapter called quadratic equations, in which you will understand that this can be solved using 3 methods. But here let me tell you only one method called factorization method. Why? Because we have learnt that we can find the 0 of a first degree expression, but here it is second degree, so it is not so easy to find its 0. So can we convert it into linear polynomials or product of linear polynomials and then easily find out? Let us see. For that, the factorization helps. So let us see how to factorize a quadratic equation. Take this quadratic equation and let this be the coefficient of x square. So before finding, you should take care to see that you arrange them in the decreasing order of their powers. So second power first, next first power, next 0 power. Like this you have to arrange them in the sequence. Now what you should do is multiply the first term and the last term. So 1x square into 12 is 12x square. Am I right? But coefficients also have symbols, and the symbols are also important. So here we have plus symbol. So plus into minus is minus. So all that we need is minus 12x square. So you multiply the x square term and the constant and put together. Now, ignoring the symbol and x square, just write it as a product of its factors. So 12 can be written as 1 into 12 or 2 into 6 or 3 into 4. Am I correct? Now, after writing like this, check the symbol you have here. If it is plus, you have to add. Please remember. If it is minus, you have to. Please remember. If it is plus, you have to add. If it is minus, you have to subtract. What to add? What to subtract? Let us see. From these pairs, you have to check whether you will get this one. What is this one? Its coefficient. I mean its coefficient. So you will decide adding or subtracting based on the symbol. And what do you add or subtract? You will add this one or subtract one from the other of these. Why should you do? And which one to take? By doing this operation between these two, you must be able to get the coefficient of the middle term. What is the coefficient of the middle term? It is minus 1. So you must be able to get minus 1 by doing some operation between these two. What is that operation? Maybe plus the addition or minus the subtraction. So here we have been given minus. That means we have to subtract 1 from the other among these pairs. So subtract 1 from the other. 12 minus 1 is 11. But we should get 1. 6 minus 2 is 4. It is 1 here. So this does not work and this does not work. 4 minus 3 is 1. So somehow we got 1. Let us think about minus 1 a little later. So this pair works for us. So let us take this pair 3 and 4. Okay. Now you have to subtract them. When do you subtract them? Because we have minus, we are subtracting them. But generally, when do you subtract? We subtract one number from the other when they have two opposite symbols. When you have two same symbols, we will add them up and put the same symbol. And when two numbers have opposite symbols, we will subtract one from the other and take the symbol of the bigger number for the answer. So here he is asking us to subtract, so we have to put different symbols for these two numbers. So if you put plus for one number, minus for the other. If you put minus for one number, plus for the other one. But which symbol to put for which number? Again this question arises. Now what we require is the minus symbol for the answer on subtraction. Yes or no? So the required answer has minus. So you will put that symbol minus for the bigger number here. Which is big here? 4. So you will put minus 4 here. So this happens to be plus 3 automatically. Now on multiplying you should get this one. So if you put here x, you multiply them. 3 4s are 12. X into x is x square. So plus into minus is minus. So now this is what we wanted. You multiply them, you will get this one. Let us check. Plus into minus is minus. 3 4s are 12. X into x is x square. Finally, this is the pair we wanted. Now, what is the purpose of this one? Simple. You are splitting this term. You are rewriting this term as the combination of these two. So you will take this one, the first term as it is and the last term as it is. So in place of middle term, you write both of them. So you write plus 3x and minus 4x. Now if you simplify, minus 4x plus 3x is minus 1x. So writing both also gives you the same answer. So it does not change its value. So it does not matter. So is equal to 0, they are the same. So instead of having one number, you have written it as combination of two numbers. That's it. Then what? You will consider first pair to be 1 and the last pair to be 1. What do? In the first pair, what can you take as common? You have 1 into x, so you have 3 into x. So x is present in both, so let us take x common. If you take x common, x remains here and 3 plus 3 remains here. So this is how we take common from the first pair. So whatever has come here, that we will copy it once more, so that it becomes easier for you in the next taking common. So now from this pair, this one is removed already. On removing x, this one from the first term, what has remained here? Minus 4. So minus 4 you will put it here, and equal to 0 will be the same. So on removing this one from the first term of this one, what you got is this one. So this is how we do it. Next, now since we have x plus 3 here and x plus 3 here, let us take x plus 3 common. So if you take away x plus 3, x remains here, and in between them there is into symbol. So we'll put into and write it as x. So from here also, if you take away this one, minus 4 remains. So minus 4 is taken common, and this is equal to 0. Finally, we have converted the second degree polynomial into first degree polynomials. Now what? Let us see. If you multiply this one and this one, you are getting 0. Means either this must be 0 or this must be 0, because in no table we get 0 unless there is one 0 among the multiplicands. So x plus 3 must be equal to 0, or x minus 4 must be equal to 0, because if it is 0, 0 into this becomes 0, or if this is 0, this into 0 becomes 0. If both are zeros also, 0 into 0 becomes 0. So this may be 0 or this may be 0. So let us see. So if x plus 3 is equal to 0, what do we know? So x must be definitely minus 3. So x will be equal to minus 3. Or if x minus 4 is equal to 0, x must be equal to 4. So there is possibility for two values which can give 0 when substituted in place of x. Let us check it first of all. So in place of x, let us put minus 3. So it becomes minus 3 square minus 1 into minus 3 minus 12. Let us see its value. So minus 3 square is 9, minus into minus is plus, 1 into 3 is 3, minus 12. So this is 12 minus 12, its value is 0. Therefore this gives the result 0. Therefore minus 3 can be considered as a 0 of this polynomial. Then does 4 also satisfy? It definitely satisfies. You can check it. So this is how we find the 0 of a quadratic polynomial. You will simply factorize first. Factorize means writing it as a product of two polynomials with degree 1. So how do we do that? You will multiply the first term and the last term and write it there. Then considering only the coefficient without symbol, you will write all its factors, and depending on the symbol, you will either add them or subtract them in order to get the coefficient of middle term. Then depending on that, if at all you have to add them, you will put the same symbol for both. If at all you have to subtract them, you will put different symbols. This symbol should be for the bigger one, and so on. You will get this one. This is replaced in place of the middle term, and so on. If you go on taking common and common, finally you will get the zeros like this. This is how we find the zeros. So we have got two zeros here. Earlier we got only one zero, and here we have got two zeros. What is deciding the number of zeros? Simple. The degree is 2 here, so we have got two zeros here. There the degree was 1, so we got 1 0. So the number of zeros depends on degree of the polynomial. So what we can say is the maximum number of zeros that a polynomial can have is equal to its degree. It is only maximum. So the zeros can also be less than the degree. That we will come across in the next steps. So if you practice finding the zeros of some quadratic equations, it becomes easier for you to solve it in your examination. Now coming to the fifth one, check whether 3 and minus 2 are the zeros of x square minus x minus 6. So he's asking us to find whether 3 and minus 2 are the zeros of x square minus x minus 6. Do they become zeros or not? How do we check it? Simple. Substitute in place of x, and if you get 0, that is really the 0, or else it is not at all 0. Simple. Let this be p of x. Then we will see p of 3, because we have to check 3. So this becomes 3 square minus 3 minus 6. So 3 square is 9 minus 3 minus 6. So this becomes 9 minus 9. So this is 0. Therefore this is P of 3 is 0, therefore 3 is considered the 0 of the polynomial. Likewise, you will substitute minus 2 also. So P of x is equal to x square minus x minus 6. So you will take P of minus 2 is equal to minus 2 whole square. Please concentrate on this, minus 2 whole square. Next, minus is from this one and x has minus 2. This is where many students go wrong. So when you have symbol beside symbol, you will put the bracket for the immediate one preceding the number. Next, minus 6. So this happens to be minus 2 squared is 4. Minus into minus is plus 2 minus 6. So plus 4 plus 2 is 6 minus 6. This is 0. Therefore, this is also a 0. Therefore, both of them are the zeros of the polynomial because their values happen to be zeros. Proved. The next one is find the zeros of x minus 1 using graph. Yes. One method of finding is equating it to 0. The second method is we can also find it using a graph. So let us see how we can draw graph for x minus 1. So simple. We know graph x-axis, y-axis. So this is y-axis. So this is x-axis. We have 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3. So let us take this graph. Now we have to draw graph for this x minus 1. How do we draw graph for x minus 1? I'll tell you an easy method. Though you can do more easily than this. This lets you to never make a mistake. Let us see. Now you will take this one and draw a box like this. In the first line, you will put the value of x. Why x? Because it is a variable present in the given polynomial. Then draw like this and draw a double line because this only decides the variable whether it is x or y or what it is. Then the next step is do take the first term, whatever it is. What is the first term here? X. So we have already written x, no? This indicates only the variable and this is a term from this one. So we have taken x, draw a line. Take the next term including minus 1. So it's minus 1. Then draw a line. So if all the terms are finished taking, there will be 3 terms sometimes. So take the first term here, second term here, third term here. Go on taking like that. Once all are finished, draw a double line again. Why double line? You will come to know. Now, take like this. You can take 5 or 7. Let us take 0, 1, 2, minus 1, minus 2. You can take in any way, any values, but let us follow a system. You will take all the numbers 0, 1, 2, 3, 4, 5 like that. You will take some positive numbers and some negative numbers to check and to test its nature. So you will take some negative numbers and some positive numbers. Preferably we take 0, 1, 2, 3 and minus 1, minus 2, minus 3. The order is not matter. You can take minus 2, minus 1, 0, 1, 2 or 1, 2, 3, minus 1, 2, 3, minus 1, minus 2, minus 3, minus 1, minus 2, minus 3 and 0 or minus 3, minus 2, 1, minus 1, 0, 1, 2, 3. You can take in any order. The order does not matter. Now, what do we have here? You write whatever it is here. So x means the value of x. For example, if it is x square, let us imagine. So the value of this value has to be squared. So if it is 1, you have to square 1 and write it value here. So 1 square. So if it is x square, on squaring 2 you will get 4. On squaring minus you will get plus 1. Like this. This decides what to do with this value. Now let us see how to fill these values. Taking this value, do what it says. So for example, 0 is the value of x that you have to do with this one. What is this? In place of this, you put this value. So in place of x, if you put 0, you will get 0 only. So take this value and put here what it says. So it is only x, so it will be 1 only. For example, let us imagine it is x square. In this, what do you get here? Let us see. Now if it is 2, you put 2 here. 2 square becomes 4. So if it is x square, you will get 4 here. So this decides what to do with this one. This has to be substituted here in place of x. Please keep it in mind. So if it had been minus 2x, let us imagine. So what do? Minus 2x is here, and in place of x you have to put 2. So in place of x you put 2, what happens? So minus into plus is minus, 2 into 2 is 4. So this becomes minus 4. Like that. Substituting this value in this, whatever you get, you have to write it here against this value. So we have only x here. So whatever is here, you substitute here. So we'll get only 2. So minus 1. So minus 2. So this is all about how you fill the table. And here you have minus 1. It has nothing to do with variable. It is individual, constant. So you always have to write the same minus 1, minus 1, minus 1, minus 1 and so on. Now, what do you get here finally? Let us take this value to be y. So 0 minus 1, algebraic simplification. So it is minus 1. So it is plus 1 minus 1 makes it 0. 2 minus 1 is 1. Minus 1 minus 2 is minus 2. Minus 2 minus 1 is minus 3. From this, you can do like this. So this one, the first one and the last one have to be taken as ordinal pair. 0 minus 1. First one and last one. 1 comma 0. First one and last one. 2 comma 1. First one, last one. Minus 1 comma minus 2. So on. You have to take them and identify these points on the graph. Let us see. 0 comma minus 1. So 0 comma minus 1. This happens to be here. So identify it using pencil and round it up, and beside this you have to write the coordinates. Next, 1 comma 0. So 1 comma 0. This one. 2 comma 1. So 2 comma 1. Next, minus 1 comma minus 2. So minus 1 comma minus 2. This way you will get all the points, and if you join them, it happens to be a straight line. So when you are drawing a graph for this kind of polynomials of first degree, you will always get a straight line. Hence, this kind of polynomials with degree 1 are called linear polynomials. Why? Because they form a line when you draw them on a graph. Hence, first degree polynomials are also called linear polynomials. And second degree polynomials are called quadratic. Why? Let us see later on. So this is how we draw a graph for this one. Now, what are the zeros? Let us see. What is a zero? Its value should become 0. This is together we called as y. Here you see, all this together we called as y. So where y is 0, there the value of x is the 0 of the polynomial. Here on this line, where is the value of y 0? The value of y is something here. So something here. You go on drawing a line like this. So at some point you will get the value of y as 0. Yes, here on x-axis the value of y is 0. So this value is 0. So here, what is the value of x? The value of x is 1. Yes or no? You see, what are the coordinates? 1 comma 0. So where the second coordinate is 0, the first coordinate happens to be the 0 of the polynomial. That is, where this graph touches the x-axis, there the coordinate of x is called the 0 of the polynomial. So when you draw a graph, it touches the x-axis at some point. In that case, there the value of x coordinate is the 0 of the polynomial.